role is installing and configuring the Hyper-V role. So it's like any other server role. It's actually free as part of the Microsoft Server 2016 or 19. You don't have to pay any more for it, and you just install it like a feature and role like we've been doing. So today we're going to talk about installing the Hyper-V role, managing the Hyper-V role, and configuring some basic settings, and talking about the storage and networking. Okay. So server platforms that provide Hyper-V. Okay, so we've sort of talked about various editions of server previously. I know this is talking about 2012, but it's the same for 2016 and so forth. But all server platforms, Microsoft server platforms, standard or data center. In this case, it's talking about Enterprise Edition. That's equivalent to our data center in Server 2016. Give you the ability to add the Hyper-V role. You can use a GUI, the graphical user interface, to manage the Hyper-V, or you can use a command line management with PowerShell. The Hyper-V is licensed per processor, and it includes virtualization rights. What does that mean? That means, if you remember, we spoke about how the standard gives you 2 virtual machines, each with Windows Server operating system for free as virtual machines, if you paid for the physical host already. With the data center, it gives you unlimited number of virtual machines for that physical server. And obviously, the licensing itself, the original licensing, is based on the number of cores, CPU cores. So you just can't, don't think you can just have an unlimited number of virtual machines. Really, it's limited by the physical resources. There's also a Hyper-V server, and which is actually free. Okay, this is interesting, because don't forget ESXi, which is VMware, is actually free. ESXi. So this is meant to compete with that. But there's some limitations, as you could imagine. It only includes the Hyper-V role. You can't turn this server into anything else. First of all, it's command line only, which means it's a server core. Yeah, so this is for Hyper-V only, yeah. And basically it's free, but the virtual machines you then create, which might be Windows Server virtual machines, need to be licensed separately, so you'll be paying anyway. So Windows 8 and Windows 10, as we know, have a 64-bit Windows client operating systems, and they come with Hyper-V as well, as we all know. Okay, we can install Hyper-V on our Windows 10, but that's not the same Hyper-V. It's limited. It doesn't have high availability or live migration functions, and it's not a Type 1 hypervisor. It's a Type 2 hypervisor. If you remember, Type 1 was bare metal. Type 2 is hosted. So here are some numbers. So this is for 2012, and obviously they're a lot higher for 2016 and 19. It's always going up, but really just need to consult the specific one you're looking at. So if we look at these just purely for numbers' sake, the logical processes, so that's how many virtual CPUs or CPU cores you create inside the virtual machines that you're running at any one time. So that's 320 logical processes. Physical memory, 4 terabytes. Virtual processes per server is 2,048. Okay, so and virtual processes per virtual machine can have up to 64. 1 terabyte of memory per virtual machine, and running virtual machines per server 1,024, and size of virtual hard disks. Number of nodes in a failover cluster, 64, which means there could be 64 Hyper-Vs in a failover cluster, meaning that you could have that many hosts protecting you against failovers. And you can have up to 8,000 virtual machines running in a failover cluster, which means you can actually protect 8,000 virtual machines from failover. Consideration for disk and storage. So we spoke about this briefly already. So Hyper-V can use DAS, directly attached storage. So, yeah, we all know DAS. They're the internal hard drives, the USB hard drives. It doesn't matter what kind of hard drives they're, as long as it's plugged in by a bit of cable to your system board. Okay. It can also use SAN, storage area networks, and obviously the technologies in that are your like your iSCSI, like your fiber, what's it, Ethernet over fiber over Ethernet. It could be fiber optics. It could be yeah, fiber over Ethernet. I said that already, and it could also be NAS, network attached storage, and that could be NFS, but more importantly for us, probably SMB 3.0. And that's a special type of shared folder. Like I said, that's a share for applications rather than just your simple share. Virtual machines require storage for obviously so we all know this because we use VMware so much for their virtual hard disks, for configuration files, for checkpoints. So checkpoints, if you've never heard of the term, is another word for snaps. And save states is another word for when you pause your virtual machine. So all of these are stored on the file system. So we need this. And like I said, we can use any of this, but to be honest, in reality, no one really uses DAS unless they're very, very small. Because basically, if you want to do live migration, if you want to do failover clustering, if you want to do replication, you need to use some sort of shared storage. Shared storage means a storage area where many Hyper-Vs can access. So instead of storing the virtual machines on our individual Hyper-Vs, they're stored in a common place. So even if the Hyper-V fails, the virtual machine files are still available and can be started again on another Hyper-V machine. And we'll talk more about that in the future. Considerations for networking. So we spoke about network cards and we needed 3 networks for our project. But let's think about it. Hyper-V should have multiple network cards. To be honest, you can the more network cards you have, the better for a Hyper-V host machine. So if we can actually have a quick look at some pictures. I like pictures. So okay, I probably spelled that wrong. So if we look at this, for example, this is one expansion card, and basically we can put that into the host server. And if you look at this, this gives you 8 effective network cards. You can buy others, which are 4. You can get 2. You can get various connections. This is fiber connections by the looks of it. But you can certainly get these ones to add extra network cards to any server. Okay, so the more network cards, the better normally. Okay, so why do we need to have more network cards? Because there's various different reasons. We should. This is the recommendations. Yeah, of course, speed is always a consideration. So obviously, we'll talk about that in the second last point, or end the last point in this slide. So why do we need so many network cards? Because there's so many reasons. It's recommended that we have a dedicated NIC or network interface card for Hyper-V management. So, who can manage the network cards? So who can manage the Hyper-V? And there's what's called management traffic. So we can actually set our Hyper-Vs to only receive management traffic on certain network cards or certain networks. So therefore, the average person on the production network that we've called it in our assignment can't just try to manage Hyper-V. It could be on a different VLAN, different physical network that the management traffic is received. You should have at least one network card for the virtual machine network. That's at least one. So what does that mean? That's where the virtual machines are using these to communicate with the physical clients. Okay, I would say at least one. I would say at least 2 realistically, because obviously if you're hosting a lot of services and the clients are accessing this, you want to obviously increase the bandwidth and also protect against single points of failure. It talks about 2 network cards for shared storage. So that's accessing the shared the storage server, whether that's a SAN or NAS. So that's again a lot of traffic, a lot of data is passed from the Hyper-V to the storage servers, because obviously every server, every virtual machine is writing and reading from the virtual hard disks. You need to have a dedicated network card for failover clustering. So that's basically communicating between the cluster nodes or cluster members so that they can actually know the state of each other, as well as for managing it. It should be a private network. It shouldn't be used for anything else. And at least 1 network card for live migration. You should use fast NICs. Yeah, obviously we've got gigabit, but obviously we've got also 10 gigabit and faster networks, as well as many other networking technology. There's another thing as well. If we only have small slow network cards or slow network, we should do both. In fact, we can do what's called NIC teaming. NIC teaming is basically, instead of using 1 physical network card, we use multiple physical network cards. So if we take, say, 2, that means we double the throughput, and we actually are protected from failure, single points of failure, because we have 2 cards at the minimum. You could have more, and protect you against redundancy. So what was that? I don't know. I saw a little thing pop up, but I didn't look at it. Let's see. Oh, sorry, that was Alex. What's the standard network speed for data centers nowadays? Yeah, it depends on what part of the network segment is being used, and obviously how busy it is. And yeah, the faster the better. So let's have a look at. Let's do a bit of research. All right, so maybe I shouldn't do pictures. Oh, you got a link for me? Let's have a look. All right, good. Where did it go? I think I accidentally closed it. All right. Yeah, so you can see that there's quite a bit of various speeds there. And if you look at what they're saying from just this graph, is that the 40 gigabits Ethernet is declining. The 100 gigabit is full maturity, which means most people are using that. And the 200 gig is in growth, which means it's starting to pick up. Whereas this is still being introduced in several years away from being as a common practice. So if that makes sense. Yeah, so basically from our point of view, it's not so much what the specific speed is of the NIC. We would obviously try to get as much as the highest speed we can afford, because don't forget, we don't need just 1 NIC, we need several. So if we actually got that network card module, what was it? If we actually looked at that, if we want to get that module, so I think that's a gigabit Ethernet anyway, but there could be probably much faster ones. It's really about the balance between the costs and what you can afford versus what you like. So we also need bandwidth management. So we don't want necessarily, if we have several virtual machines using the same virtual switch, you don't necessarily need one to be hogging all the traffic. So you can actually do a couple of bandwidth management, such as limiting the amount of bandwidth a certain virtual machines can get. So there'll be sort of consistent thing we'll be talking about, that not all virtual machines are equal. Okay, it's not an egalitarian society of virtual machines. It's like we said. We're sort of like a shrewd business people where we will give resources to ones that we believe are actually valued, and will not give resources to things which are not as valued. So that's just the fact of life. Considerations for high availability. So high availability means keeping your systems up. What's that? Altruism? Is that altruism you just typed? It disappeared before I can read it.
Sorry, it's utilitarianism.
Utilitarianism. Yep. Sorry, I saw that pop out quickly and disappeared. Yes. Yeah. The the needs of the many outweighs the needs of a few type situation. All right. So basically, so consideration for high availability. So Hyper-V hosts has failover clustering that we'll talk about in the future. There's also virtual machine-based clustering, which basically means that the virtual machines themselves can be clustered. Okay, so cluster roles in the virtual machines are highly available. There's virtual machine network load balancing, which are highly available and scale out web-based applications. Let's give you some examples. So for example, if you got two virtual machines, they're doing the same role, and they're like, for example, two web servers. They have the same roles. They have the same hosting the same website. By using the Microsoft Windows network load balancing, we can actually load balance between both virtual machines or many virtual machines, which are hosting this web-based application. There's application-specific clustering. So the program, or the system you're using, like for example, Microsoft. If you're using Oracle database, which is sitting on top of a Microsoft server, you don't have to necessarily, even if you're doing nothing else. So if you're not doing host-based failover clustering or virtual machine-based failover clustering or even network load balancing, you can actually do clustering within the Oracle database between one Oracle database server and another Oracle database server, so that they, through the Oracle database, they're clustering their information. So there's many things you can do. Okay, starting with hardware, to wiring, to power, to many other things, and then working inside the host, the virtual machine itself, the operating system, and then the application. So at each level, you can do something. So some changes. So once you install Hyper-V, there's now, guys, can you hear me?
Yeah, I can hear.
Yes. Yeah, I'm not sure what's happened. Basically, it looks like everyone was off, and then everyone was reconnecting, and
Yeah,
now
it was
I think
we were all talking to each other, but yeah, you disappeared as well.
I disappeared. I could see all your chats
Okay.
and stuff like that, but I couldn't talk, and my thing was in the state of reconnecting. Could you hear each other? Could you hear each other at all, or was it just chat that
we weren't trying to talk. It was just all on chat.
Yeah, it's just a chat.
Yeah.
Try.
Same thing.
No, I could see your chats. I think the first one I saw was Alex saying, "Oh, sorry." The first one was Alex saying lost connection, and then Matthew and all that kind of stuff. But no, I could see your chats on, as you can see here, but I couldn't see. I guess you guys couldn't hear me. Let's continue on. So some changes to your server once you install the Hyper-V role. So the hypervisor is added and it started automatically, and the Windows server is moved into a parent partition. All right. So let me just highlight that. it sort of almost goes over. It almost goes as if it's no big deal. It's moved to a parent partition. What's the big deal? No big deal at all, and moves on. So remember how I talked about how the Hyper-V on a Windows 10 is what's called a Type 2, a hosted virtualization, a hosted hypervisor, whereas the Hyper-V and obviously vSphere ESXi are what's called Type 1 virtualizers, hypervisors, which means they're bare metal. But if you think about it, the way we're describing it is that we've installed Server 2016, then we add the Hyper-V role, don't we? Doesn't that like as if you're adding the Hyper-V role on top of 2016? Isn't that similar to installing VMware Workstation on top of your Windows 10? So how can that be bare metal? Do you guys think about that, or did that come up as a bit strange for any of you guys? But if it didn't, it should have. But also it talks about how Windows Server is moved into a parent partition. That's a key point. So when you're installing Hyper-V on top of your server, you're not really installing on top of your server, if you like. What you're doing is you're sliding it underneath your server. Okay? So what it happens actually is you're installing the Hyper-V role and you're turning the Windows Server operating system that was already on it into a virtual machine. And this virtual machine is moved into what's called a parent partition. It's a special virtual machine for actually interacting with the Hyper-V itself, as well as managing the Hyper-V. But it's still a virtual machine, nonetheless. So therefore, it's sliding the Hyper-V underneath the server. So these additional tools, so the Hyper-V management tool is added, additional services are added, performance counters are added, application and service logs are added, and the Hyper-V administrators groups are created, and the Windows firewall rules are configured to allow Hyper-V to communicate. So here's some services that are added to your server once you've installed it. So if you're not sure if your Hyper-V is installed, if you see any of these services, then you know it's installed. Managing the Hyper-V. So if we look at this interface, this is a little bit outdated in the sense that it's very similar to what we see in the Server 2016 and also 19, but just the look and feel looks a little bit outdated because this is a picture from 2012, obviously. But still the same things. We know that Microsoft interfaces hardly ever change dramatically. Typical Microsoft Management Console, you got the nodes on the left. Okay, in this case, you've got the two servers, Hyper-V servers, and obviously by selecting any one of them, we'll see the virtual machines that's on it in the middle, and with actions on the right. And here the checkpoints, like I said, are like snapshots, and we can have a look at some of this, the amount of memory and so forth down here. We can click on various tabs here to look at other information. So here, these are settings specifically to do with the Hyper-V server, and these are settings, functions you can add, you can do onto the virtual machine that you've selected in the middle here. So when you look at here, you got settings here and you got Hyper-V settings there. So when you click on this, this is the settings of the virtual machine, whereas this is the settings of the Hyper-V. All right, you can see that this virtual machine is highlighted from the naming. It's London domain controller. It's running. It's got 25% CPU usage, about 3 gigs of RAM, and it's been up for 8 hours. So that's kind of information you're getting. And with this virtual machine, you can see that there's a couple of snapshots created or checkpoints. There's one where it's actually promoted, DC promoted. Obviously, that means promoted as a domain controller. And then VMM, which is where you've got the virtual machine manager, which we'll talk about in the future, installed, and they've created snapshots at these points. Adding the Hyper-V management console. So there's a tool, which is this thing, the Hyper-V management console. You don't have to be on a Hyper-V server to have the management console. You can just add the management console onto other computers or servers, and then just connect to the Hyper-V and manage it remotely, similar to what we've been doing with many other things. So we can actually add the feature or turn on the feature. So for example, on my system here, control panel, programs, turn on Windows feature, and you can see that if we expand Hyper-V, the platform is the Hyper-V on my Windows 10 here, but we can actually also install just the management tools or the PowerShell commandlets, the modules for the PowerShell Hyper-V. And if we do that, we can just use it to connect to a remote Hyper-V machine and manage it. And obviously, if you can also use remote desktop or RSAT, which actually is a tool that you install on your client computers to turn it to a remote system administrator terminal. There's PowerShell, so probably sick of me saying it. Anything you can do with a graphical user interface, you can do with PowerShell. And it's probably more with this Hyper-V stuff because there's what's called remote PowerShell, which means we can actually execute PowerShell commandlets on our system here, enter it here, but execute it remotely on a system elsewhere. And if you remember, we spoke about the nano servers, which are basically headless, meaning no management console at all. Basically, that's how we would manage it. We would manage it remotely. And the nano servers are the best Hyper-V hosts because they are a very small footprint, specialized with minimal set of services and drivers and so forth. Hyper-V can be in a work group, which means peer-to-peer network, but domain membership makes it significantly easier to manage, and that's what we'll be discussing from now on. We can enable remote management in a work group, but you can see that we have to do something with the firewall, create a local user, add the local user to the Hyper-V administrators group, grant administrative access remotely to local users, and then connect to the Hyper-V host using the Hyper-V console. But if it was a part of the domain, as long as we're logging in with the domain administrator, they are also Hyper-V administrators, and we can delegate other users as Hyper-V administrators in the Active Directory and get that the ability to manage it as well. There's what's called a BPA, so there's probably BPAs for everything Microsoft, but BPA for Hyper-V is what it stands for is Best Practice Analyzer. And Hyper-V BPA has 110 different rules to assess whether you're doing it the best practice or not. So it's, for example, one of them is that Hyper-V should be the only role enabled. So your Hyper-V shouldn't be doing anything else. Like I said, Hyper-V is the workhorse of your virtualization infrastructure. If it's a workhorse, so busy working on virtualizing virtual machines, it really shouldn't be doing anything else. Whether it's a domain it should be a domain member, and BPA is available in Server Manager as well as the Windows PowerShell. You can scan one or multiple roles locally or remotely, and you can filter your scans, and you can look at compliance with the scans. So there's some like typical error levels, whether they're error, warning, or information, a bit like what we see in our event viewer. There's a Hyper-V security model, which uses authorization manager controls the Hyper-V security, and challenging to use. It's not suitable for complex security rules, and it's deprecated but still available. Deprecated means appreciated, should I say? What that means is actually not being used, not being carried forward in the future. So we shouldn't really talk about it. Overview of the Hyper-V settings. So we can configure various things, but obviously some of the important things include where the virtual hard disks, where the virtual machines are stored by default. Physical GPUs, the NUMA spanning, we'll talk about NUMA in the next slide. The live migration, storage migration. Live migration is moving of the virtual machines without downtime. from host to host. Storage migration is talking about moving where the virtual machines are stored without any downtime, hopefully, and how in this case it's configured as two simultaneous. There's replication, which we'll talk about. There's the keyboard release. We can change that if we want to. So obviously, it means when you click into the virtual machine, how do you release it from the virtual machine to the real machine? And basically use the virtual keyboard, and also, also a couple other settings there. But what is NUMA? Okay, it's non-uniform memory allocation. Okay, enables a host to scale up the CPU and memory. Partitions the CPU and memory into NUMA nodes, and allocation and latency depends on the relative CPU location. Hyper-V presents NUMA technology to a virtual machine, and guest operating systems can make their own decisions on how they use the resources. And the main reason is that it minimizes cross-node memory access, which means the memory of one virtual machine cannot be accessed by another virtual machine, obviously for security and stability reasons. There's NUMA spanning, enables that the host level. Virtual NUMA technology can be configured at the virtual machine level, and by default, a virtual NUMA aligns with that of physical NUMA. There's remote FX. Okay, so basically, this basically provides a remote desktop experience that may be equivalent to physical desktop environment. And the system requirements is that you need to use the GPU, second level address translation, remote desktop, virtualization host service role. And basically all of this really relates to how you interact with the virtual machine. For example, if you've got a touchscreen on your physical machine, how does that pass on those gestures or the touch from your physical machine to the virtual machine? How does it redirect the USB, the media streaming? So if you're streaming media from your virtual machine, does it play the media out of your physical devices like speakers? Okay, so this is talking about that. So enhanced session mode is a remote desktop over VM bus, full remote desktop capabilities like including shared clipboard. So in this enhanced session mode, it's a bit like what we do with the VMware tools, where we can paste data from a physical machine to the virtual machine, redirect smart cards and USB, as well as folder redirections. So we need to enable at the host, Hyper-V host, guest operating system is required to be one of these. And basically what is enhanced session mode? Virtual machine connect, basic experience, virtual machine management service, the virtual machine process, and then goes to the VM bus. But with then applications and all that communicate with the keyboard, video, and mouse drivers through the VM bus to the hypervisor. But with enhanced session mode, basically we add this remote desktop services, which actually gives us that feel that we're using a remote desktop, which allows us all the functionality that remote desktop allows us, which is the copy and pasting, shared clipboard, and so forth. What are resource pools? Resource pools are logical containers of resource, as the name suggests. It's a layer of abstraction between the virtual machine and the hardware. So abstraction, if you never heard that word, is actually something that hides how it actually really is. Okay, so it's a layer of abstraction between the virtual machine and the hardware. So basically, from a point of view of the virtual machine, this is what they see. But reality is this is the hardware. So it basically presents this hardware resources to the virtual machines in a certain way. Virtual machines are configured to use the resource pool. Virtual machines can use any resources from the configured pool. And it's helpful when you're moving virtual machines. Resource pools can be used for chargeback. Different resource pools can exist, such as processor, memory, Ethernet, and virtual hard disk. And resource pools can be configured by Windows PowerShell. So if that doesn't make sense yet, what we're talking about is we're allocating amounts of resource to what's called a resource pool. We can define virtual machines which are members of this pool, which therefore uses resources out of this pool. So basically, it's as the name suggests, it's a big pool of resources. If your company, for example, has 20 virtual machines which is utilizing this resource pool, it doesn't matter how much each virtual machine uses, but they've got this pool of resources to use. It says it can be used for chargeback. Just imagine you being a hosting company and you're hosting the virtual machines for various other companies. Well, you could define a resource pool so that each company doesn't affect another company's resources. And also, if this one company wants a large resource pool, whereas no one wants a small one, you can charge them based on different amounts of resource being allocated or being used in their resource pool. Okay, storage and networking. So demystifying storage appliances. What storage appliance? A storage appliance is basically a device that has storage. And these days, they are usually similar to a computer. They have 32-bit or 64-bit processors. They have RAM or memory. They have network adapters, and they have storage host bus adapters. Effectively a computer. So you have a front end and a back end. The front end is what it is presented to the servers, and the back end is how the information is stored. At the back, you have multiple physical interfaces, pools of disks presented as LUNs or logical units, and they could be simple, mirrored, or parity. A bit like what we're talking about with the storage servers in the ICW. At the front, so these are disks. Okay, what kind of disks, it doesn't matter. They could be all sorts of different disks, could be solid state hard drives, could be mechanical hard drives, it doesn't matter. What is at the front is the important part, okay? What's at the front is how the servers connect to this storage. So like I said, it presents this to the servers, whether that's a Hyper-V or vSphere. It can be presented as iSCSI, which is SCSI commands. So SCSI, if you don't remember, are small computer system interface. It's a way of connecting internal hard drives on server grade machines. But it's iSCSI, so that's SCSI instructions over IP. So think about that. It's basically accessing the hard drives as if they were internal hard drives, but sending it through a TCP/IP network. There's also FC and FCOE. FC stands for fiber channel. So using fiber optics to communicate to these disks, and FCOE is a fiber channel over Ethernet. So again, sending fiber channel commands over Ethernet. NFS and SMB are the network file sharing type app protocols. NFS network file system is Linux based, whereas SMB, as we all know, are the Windows type shares. So these are how the Hyper-V computers are configured to connect. In the front, by the back, you have various disks configured in those pools and so forth. We can also have them clustered, so we can have storage clusters. So which means instead of having one storage area network or server, we can have multiple ones. And we can deploy two or more for a scale out, storage solution. And we have these servers. These could be normal servers, could be just regular servers, but they could also be Hyper-V servers. And the Ethernet, 1 gigabit, 10 gigabit, these are a little bit old, like we saw before. They can be a lot faster now. And the fiber channels, again, these various speeds. So if you remember, we spoke about storage spaces, which basically effectively turns your server 2016 or 19 into a SAN server. So we can actually turn them in there, and we can actually create iSCSI, SMB3, and we can use these speeds. There's also a cluster in the box. So effectively, instead of actually buying two physical devices and clustering together, you can buy a cluster in a box. So if effectively you have this system, and it's like having two computers or two servers side by side, wired in a certain way. So its availability, at least one node will always be available despite failures or replacement of components of other node. It talks about dual power domains. Basically means they're plugged in with separate power supplies and also onto separate circuits. Simplicity is pre-wired with internal interconnects between the nodes and controllers and storage. Flexibility, so PCI Express slots for flexible LAN, external SAS ports, so SAS is the serially attached SCSI, ports for JBODs. JBODs are just a bunch of disks, so they're disk arrays if you like, for disk array expansion. It uses office level power and cooling and acoustics, so the noise level means it can actually be fit under your desk. So you could buy one of this as a small business and have your solution in a box. So traditionally, fiber channel iSCSI is the way to go, and I think with the VMware vSphere, that's what they like to use. In fact, I personally recommend this. Well, Windows file server cluster with storage spaces, effectively with promoting Windows Microsoft solution. Traditionally, we have storage tiering. That means levels of storage. If you remember, we could have slow, cheap storage and mechanical hard drives, and fast, speedy, expensive solid state. But we move data around to be best use the storage based on performance and the amount of usage. There's data deduplication, as the name suggests, removing duplicates, storing one instance rather than hundreds of instances. There's RAID redundancy for resilience. There's pooling of disk. There's high availability. There's persistent write back cache, copy offload, and snapshotting. Okay, this copy offload means that once you start the copy process, you don't need to be involved. It's taking place in the background. Whereas the snapshot, you're probably familiar with virtual machine snapshots, but with the storage server, you can take snapshots of the storage as well. That's on a traditional, things you can do on a traditional storage. And this sounds like a promotion of Microsoft's file server cluster with storage spaces. It is. It's basically saying, whoa, with our Microsoft server that you already know, you can also have storage tiering. You can also have data deduplication. You can also have resilient options and so forth. Okay, so with the storage tiering, like I mentioned, you could have solid state hard drives and hard disks, and you could just store your data here. But when something is being utilized by many people or servers, they become what's called hot data, and they get moved from the mechanical hard disk to the solid state. And if they stop being used, they become cold and they get moved back. So this is effectively, you guys might have heard of the term the hybrid drives, which is some solid state hard drive and some mechanical hard drive. You can buy that and for your laptop and so forth. This is effectively turning the server into a hybrid drive of sorts. So you're using the fast solid state portion for the highly demanded files and resources, whereas you're using mechanical hard drive part to provide you large amounts of storage. So best of both worlds. So it costs, you get the cost benefit of having the mechanical hard drives, but you get the performance advantages of solid state hard drives, and this is happening in the background automatically for you. You can also pin, which means you permanently say this file, this resource must be in the solid state to be in the faster tier. So storage pools are a collection of disks. Storage spaces are virtual disks which are created in the storage pools, and then we use that. We create volumes on that. Storage spaces features, it has resilient and integrity on standard disks, has continuous available and CSV integrations. CSV is clusters shared volumes. Optimal storage use and optimal storage tiering, like we talked about just then. It supports multi-tenancy isolation. Multi-tenancy is where we are hosting services or virtual machines or files for multiple different companies. We're a hosting company, and we can keep them isolated from each other. Data deduplication, we've spoken about this in 5ICW. Basically, if I send you guys a file, and you all download that file from your email and you store it on your network drive, you're basically, if there's 20 of us in the class, we're storing it 20 times. If that was 10 meg file, if we're storing 20 times, that's 200 megs of storage space we're using on the server. So what data deduplication does is it actually scans your storage and looks for duplicates, not by the file name or where it's stored. It's actually looking at the bit level as scanning to see if they're the same. If they are the same, they will remove other copies and just keep one and reference it from from wherever it's stored. So therefore, you still store it where you want to, but really you're accessing it from the same place if you're storing it multiple times. It can significantly reduce the space of your virtual of your storage, and obviously reduce the amount of space you're using. And this is very important because obviously a lot of our virtual machines has very similar files. So especially for VDI, that's a virtual desktop interface, which instead of actually having physical computers, full-on physical computers in front of every user, you have a thin client which connects to a virtual desktop interface on a server. And if we're talking about Windows 10, if we have 100 users which are using VDI, then we have 100 Windows 10 instances in our Hyper-V servers. And yeah, and obviously that means that all these 100 instances will be very similar. So they're removed as duplicates. Yep, sorry guys. Am I sounding like a robot seriously, or just because of the way I talk?
I actually don't know how to answer that one, Alex.
Yeah, I can't help it if it's just the way I am.
It's the internet connection most likely doing something everyone uses it at this time of day, don't they? And it just gets quite bad. So I can't actually see a screen I can't see a screen right now, but I can still hear you.
So if we look at, I know you can't see it, Matthew, but for the rest of us, you can see there's Alex had only 2 bars just then. Matthew's got 2 bars. Navdeep's got 2 bars, and Navdeep's just gone up. So if I focus on Matthew, who seems to be the one that's down, he's got a download of 73 kilobits per second. And he's,
don't rub it in how bad it is.
No, I'm not saying that's but that could be the reason. Okay, so
that's all good.
The first thing they do is stop the video because obviously that takes a whole bunch of data. Okay, so let's just push through and see if we can finish this very soon.
I mean, it's going to be on the recording anyway, isn't it? That's the thing.
Oh, so hopefully it doesn't record me as a robot either. So, so the what is offload data transfer? So let's look at the picture. That probably is a little bit easier to understand. So normally when you're using your Windows 10 and you're exploring a shared drive, like a map drive, should I say, that's on a file server. And when we actually want to copy a file from one area of the file server to another area of file server, what happens is that it actually downloads the data to our computer and it rewrites it to the new area on the file server. You can see that, well, it's using the network to copy the file to our computer before it copies it back to the server. I mean, I'm sure you guys see how inefficient that is, isn't it? What offload data transfer is instead of actually doing that, it's actually going to issue a command to the file server that's capable of this, of course, and it's going to have a token, which basically means I'm going to take this data and copy it to this new area. So instead of actually our computer being involved in the process, it's going to happen on the server, which minimizes the LAN traffic that we're talking about. So obviously internally it's going to be a lot faster than if we had to go travel through the network and back, because there's no point of that. It's copying from one part of the server to another part of the server. So basically, what the copy offload allows us to actually just transfer the data within the same cluster storage array without involving our computer. As you can see, it's a lot more efficient. That's what it basically is. And obviously, our storage server, if it's capable of that, it makes life a lot more efficient. SMB free, so it's version free. It's a network file sharing protocol, SMB, server message block. You might see as MSCIFS, as in the firewall rules, if you've ever seen that. So MS, Microsoft, a common internet file sharing file system, or it's file sharing, I can't remember which one. But basically, it's been around for decades. Okay, SMB. In fact, if you use Linux, you might have heard about the Samba server, which basically is a Linux service that shares a Linux file system via SMB, or a server message block. It's a version free, obviously 3.0. So that's not your typical Microsoft share. It's a share. It's a version free share. What does that mean? Version free support be used as scale servers. You can use multiple channels, which means you can communicate a lot faster. And we can use SMB direct, which is SMD over RDMA. You can also employ SMB encryption, and then you can also use a volume shadow services for SMB shared file shares. You can be managed by PowerShell, but SMB 3.0 must be available on both sides before you can use it. So when you create an SMB free share, you can't just create it by right-click on a folder and sharing it. That's just creates your a basic SMB share. Let's fire this one up. So this is obviously not the same virtual machines we use in our labs, but I can give you a quick demo of what is how to create a SMB free share, or it's another word. It's a share for applications. Okay, so if I open up my folder, I've got a C drive for this one. I'll just create a new one. We'll call it SMB free. All right, so instead of right-clicking and sharing, which will create a basic share, what we do is we go to the server manager, we go to file systems and services, we go to shares, and then we actually go, let me full screen this, we go tasks, new share, and this is where we share, not just advanced share. Okay, so this quick share is the one we do manual when we right click and share it, which is suitable for general file sharing. Advanced options allows you to set the permissions as well and enable quoting, and that's fine, that's great. But we can also do SMB share for applications, and if you look at this is specifically for Hyper-V databases and other applications. So if we do the SMB share for applications, it will custom path, we'll browse to the SMB, select folder. Basically, that's what we're going to call it, SMB free. That's the path. And at this point we can encrypt the data access, like we spoke about how that's an ability. And we can set the permissions if we wanted to right now, but it won't. Confirm it, and now that is a SMB free share. So slightly different to how we create a normal share. But if we don't create it like this, it means our virtual machines can't run from the shares. Hyper-V data files stored on network shares. A virtual machine configuration can be stored. The VHD files, which are the virtual hard disk files. So I know in VMware uses VMDK, but in Hyper-V uses VHD or VHDX, depending on what generation it is. The checkpoints or snapshot files can be stored on the file shares, and Hyper-V supports file shares over SMB3 or newer. Not older ones, the newer ones. File shares in Hyper-V must be on separate servers, and they must be the same members of the same Active Directory. Makes life flow so much easier. Running virtual machine data files can be deduplicated. This is for that virtual desktop interface. Reliability, availability, and performance as a SAN uses the SMB features. And benefits, it's easier to provision and management, and uses existing infrastructure. So it's using existing things, technology, and services that you may already have.